Hi, this is Peter Wheelhauer, and this series of videos is about the assumptions and limitations of social science. We're talking about data in politics and policy. We're talking about the application of quantitative methods of political analysis to political questions. And so we want to think about social science as an extension of the natural science, and to think about the role of political science and our assumptions in terms of understanding what we can and can't do with social science. When we're talking about empirical political science, we're talking about a specific kind of information process. Empirical political science builds knowledge using scientific methods applied to political phenomena. So what we're talking about here is then we have to identify then and define our terms. What do we mean by these? Well, by empirical, we mean based on observation or experience. That is, empirical means we have gathered information, we have examined it, we've observed things happening, or we've gathered records of things happening, or sometimes we can build out of our own personal understanding based on our own personal experience, and that is empirical. By scientific methods, we're talking about a set of explicit methods that we can use and make clear to others to arrive at information, gathering rules, and then interpretations that others can verify. This is not the same thing that they can verify that we are morally correct or that the implications that we draw are correct, but they can verify that we've gone through a specific set of clear processes to get to the conclusions that we draw, to gather our data, to analyze our data, and to interpret our data. That's what we mean by the scientific method. Empirical political science, then, is based on a search for regularities in observable political actions, events, opinions, and relationships. So when we're talking about empirical political science, we're saying, life is not random. People's actions are not random. We think that there are regular ways that people behave. So for example, we might observe that on a relatively consistent basis, the more education somebody has, the more likely they are to vote. The more ideological someone is, the more likely they are to vote. The less ideological they are, the less likely they are to vote. So when we can start to track these different patterns, including differences between important social groups in our society, then we're saying there's some regularity and predictability in these actions that people take in politics, these actions that politicians take, the effects of institutions that we set up as a society. So empirical political science says we think that there are some regularities that are likely to be there in society and in politics, and so we're going to try to identify those and think through the hard questions about how to carefully evaluate whether or not those ideas and those actions are actually regular, and what kind of relationships there are between different factors that are of interest to us. Now, this kind of gets big picture, but it's important for us to understand in this process that political science is a form of social science, and the social sciences have adopted, by and large, a set of tools that were developed for natural science. So I think it's helpful for us to think through what actual kind of like the tradition of science generally, how they approach their research questions and how they approach the study of whatever they're trying to study, and then look at how that gets applied in those of us who study political science. These same kind of questions could apply to psychologists and sociologists and so forth, but obviously I'm a political scientist, so I'm focused here on political science. So one underlying assumption of all scientific analysis is, if you think about geologists or chemists, biologists, and so forth, an underlying assumption is that this world is real, right? That events actually happen in the world around us, that we can see earthquakes, we can see stratification of the landscape, we can see soil erosion, we can observe chemical reactions in a lab, we can observe chemical reactions in the wild. So there are actually events that actually do happen in the world around us. And that when we're talking about the natural sciences, that there are natural causes for the things that do happen. So if a tree falls in the forest, does it make a noise? Well, this is kind of a philosophical, but it's also a scientific question, right? That if you have a noise, that something must have caused the noise. So there are natural causes for the things that happen, including chemical reactions, growth of things, erosion of things, and so forth. So all of science, the whole scientific endeavor is premised on the underlying assumption that events do happen in the natural world and that there are things that cause things to happen. That's a fundamental assumption. A second underlying assumption is that we can look at the natural world and we can gather information about effects and causes. We can look at the events and we can say, well, I think that this is likely to be the reason that this happened. And climate change is a great example of this, because people who study climate change are saying, we see this happening, we're going to measure this set of temperature changes or this set of sea level rises, and we're going to say that there are some of the causes of that can be identified in the natural world. And so they measure things that are going on in the world, and then they attribute the effects that they see, the changes in climate, to the causes that they've identified as well. This happens in all kinds of science, not just climate science. Finally, a kind of a core element of all scientific endeavors is that in general, there's substantial consistency in causes and effects. That when we look at all things being equal, when we look at the natural world, that when things happen, other similar things happen, right? Or other things happen on a relatively consistent basis. So we can then develop predictions. So even though we make a lot, publicly we tend to make a lot of fun of weathermen, one of the weather forecasting, in fact, what they develop is models based upon what they see in atmospheric conditions, what they observe, and then they connect with what's going to happen in the future, because they think that there's a substantial set of effects that can be attributed or tied to a certain set of prior conditions. So we happen to live here on the east side of Lake Michigan, and one of the reasons that we get so much snow is not because there are massive winter systems moving through our area all the time, but because we live next to a very large body of water, it turns out that that particular geographic situation, combined with certain other meteorological conditions, produces a lot of moisture in the air for the people who are on the east side of this body of water called Lake Michigan. And so we can, by and large, predict that our area is going to get more snow and more rain than, say, Detroit, which is a couple of hundred miles to the east of us. We can identify consistency in causes and effects in the natural world. There's an orderliness that's there to be found, right? And that we see this orderliness that occurs over a long period of time. So the natural world is largely predictable. And so we can make projections about what's going to happen in certain areas based upon other things. So we can develop hypotheses about chemical reactions when we gather certain information and base that on previous findings. So all of science operates this way, right? All scientists believe that events actually happen. There are causes for the things that happen, that we can learn about causes and effects, that we can gather evidence from the way the world works, and we can evaluate causes and effects and develop mathematical models and probabilistic models about the relationship between causes and effects. And then there's a general kind of an overall consistency or uniformity in the way causes and effects happen, and we can develop multiple models to make better and better predictions, but those are founded in the observation and gathering of information and evidence about how the natural world operates. Now, in the social sciences, we also do this. So let's quickly look at how this works in political science. We look at the first assumption. Events actually happen in the world around us. Well, in political science, we apply this to politics. Political phenomena, stuff, actions, behaviors, decisions actually happen. when I went to vote as a political scientist, I would say, this person actually voted. So there's something that actually happened. And there are reasons that things happen or don't happen. So we can then take that information, we can say, we have a fundamental belief that some people vote, some people don't, and there are reasons for it. Or some bills get passed, other bills don't get passed. There's a reason for that. Or some presidents will nominate certain kinds of judges, and they won't nominate other kinds of judges. Some kinds of judges will be approved, other kinds of judges won't be approved. Our underlying assumption is that political phenomena do happen in the real world, and that there are causes for the things that we see happening. With the second assumption, we can identify that relevant evidence can be gathered to ascertain whether or not there's a relationship that exists, whether a causal relationship exists, whether correlation exists, and we can develop models to help us understand the nature of that. And a big part of this class that I'm teaching on data and in politics and policy is based upon these measured concepts and understanding the nature of correlation and causality. But an underlying assumption of political science is that if we gather the right evidence, we can determine what causes and effects are in the political realm. And then finally, in the same way that we think that there's in the natural world, there's substantial consistency in causes and effects, we also think that when we're studying political behavior. The actors' actions, presidents' actions, members of Congress's actions, governors' actions, voters' actions, candidates, nations' actions, they're relatively predictable. The reasons that people and organizations act do change, but they're also fairly predictable. And the thing about empirical political science is that we can start to say, well, how much of this is predictable? How much do we know? And how much accuracy can we gain in our prediction? The fact that we know that there are some things we don't know doesn't mean that we think those things are actually random, that there's some kind of a metaphysical dice being rolled that cause things to act in unpredictable ways. No, we think that there's just ungathered information, unknown causes that help us that we don't measure yet, but that could still be relevant to particular people. So the realm of political science as an empirical set of research processes is clearly tied and clearly connected to what all of science does in the natural realm. Now, those assumptions look pretty fundamental, but the more and more that I've acted as a political scientist, the longer and longer I've spent doing this, the more I'm convinced that it's important for us to acknowledge that even our assumptions that we saw in the previous slide, even our assumptions have assumptions. There's underlying stuff that's deeper beneath the assumptions that we just talked about. So let's take some time and look at those. And some of these are intuitive, and others of them seem kind of ridiculous to state. But when we start talking to philosophers and metaphysicists, they start talking about whether or not these assumptions are true. So let's take a look at these. So the first set of assumptions that we talked about, events happen in the real world. Events actually happen in the world, and there are natural causes for the things that happen. We see this, we talked about the political application of this, right? But what is underneath that assumption, right? Why do we think this is true? Why do we think that events actually happen? What do we have to believe in order to believe that events actually happen in the world around us and that causes actually cause other things to happen? The causes have effects. Well, the first underlying assumption is that it's a true statement that the world is real, that the things that I'm interested in are real, and I am real. I gather information, I can see that it happened. There's an actual thing that happens, right? So in order for me to say that events actually happen in the world around us, I first have to believe that the world is real. If the world isn't real, if we're in a computer simulation, if I'm just a brain in a vat, then then there's this whole kind of discussion about social science is completely useless. So an underlying assumption of all scientists and all social scientists and all people who actually think much is that the world actually is real. If you claim that the world is not real, that the natural world around us is not real, then what are you doing? Why are you arguing with me? The second underlying assumption is that it's true that the phenomena that occurs have causes and effects, and that we can know what they are. So the first assumption is there are natural causes for the things that happen, and underneath that is that it's true that there are causes and effects, right? And that those causes and effects are real and knowable. Not that they're imaginary or unknowable. There are some things that we don't know, fair enough. But that's not the same thing that the stuff that we never know, right? So an underlying assumption of the first assumption is that it's true that phenomena are happening, and that causes and effects are there, and that we can know about them. And then finally, if you've taken an introduction to philosophy class, you're familiar with the fundamental rules of logic, the laws of identity, non-contradiction, and the excluded middle. In order for the first assumption of scientific analysis to be true, you have to assume or be convinced that the fundamental rules of logic actually operate. Now, I don't have the time really to go into these laws of logic, but I encourage you to take some time and research these and to understand how important they are to systematic scientific thinking. And that will actually, understanding these will help you to become more logical and more consistent in the way that you operate. So this assumption here, events actually happen in the real world and their natural causes, has underneath it a structure of ideas that make that plausible. Well, we can do the same thing with the other two assumptions, and I'm going to run through this a little bit more briefly here. So these first three assumptions of the assumptions, they apply. We're going to add in a couple more when we look at the second and third assumptions of scientific analysis. Here's the second assumption. Evidence from the natural world can be used to learn about causes and effects. Now, this assumes, first of all, the first three assumptions, right? It assumes the world is real. It assumes that the causes and effects are real and that we can know it, and that laws of logic operate. But the second assumption here, evidence from the natural world can be used to learn about causes and effects, has two more assumptions underlying it that make it true. First, it is assumed that human reason, using our powers of observation, is a relatively reliable method or tool for acquiring that knowledge. So if it's true that phenomena occur, and it's true that causes and effects can occur, how can we possibly know it? We know it because human reason is a relatively reliable tool for doing that. Now, are there problems with human reason? Do we make mistakes? Absolutely, all the time, and we'll get to that. But a fundamental assumption is that our own abilities to reason and observe and to make connections on a mental basis is a relatively reliable method for acquiring knowledge. And we can use our mind and we can use observation to connect events, causes, and their effects. So the underlying assumption here is that there's evidence out there about causes and effects. As scientists, we're assuming that we have the skill set naturally and maybe enhanced with other tools to acquire that knowledge. Finally, a fifth underlying assumption of this second assumption is how we communicate about this. An underlying assumption of all science is that human language is an inherently meaningful way to communicate information, and that this is how we talk about and pass down our knowledge about events and causes and effects. Without these two additional assumptions, we can't have any confidence that what we observe is there, that we have the ability to understand anything, or that we have the ability to communicate with others anything about anything. Scientists have to assume that human language is inherently meaningful, that our words mean something, definitions matter, and that we have to be extremely clear about our definitions and about the meanings that we're using when we have particular kinds of words. When we're using particular language, we need to understand what that means and communicate that clearly. Finally, this third assumption, substantial consistency in causes and effects, that also has these same set of assumptions. In order to make predictions about the future, we have to have the ability to gather information. An event actually has to happen. Causes and effects have to be plausible and happening. We have to be able to observe it. We have to process it. We have to communicate it to others in order to make a projection about the future. So even the underlying assumptions of our scientific analyses have these core underlying assumptions that provide a structure for conducting scientific analysis. If somebody rejects any of these, then they have a very difficult time doing scientific analysis. They have a hard time making any kind of scientific claims because science assumes all of these things are true. If you don't assume they're true, or if you don't think that they're true, then it becomes incredibly difficult for you to reconcile being a scientist. If you don't think that we human beings have an inherent ability to communicate, that our own human reason can be used to make arguments and to make observations, or that things didn't actually happen, this world is fake, that's an interesting philosophical argument. But in order to be a scientist, you've got to understand and believe that it's actually true, that we do exist. Finally, there are limits to science. Oftentimes, in our culture, we tend to think or buy the argument that science is the answer to everything. But the fact of the matter is that science itself is limited to the natural world, and political science is limited to human behavior and what we now can understand about humans as limited human beings. They can't tell us, our sciences can't tell us everything. And let me give you just a few examples of why science is not the answer to everything. It can't tell us everything. First of all, large portions of the human species, for all of its existence, as far as we know, understand or believe that there are non-empirical and non-natural phenomena that exist. For example, when we think about beauty, right? What is beautiful? If I think about a sunset, right? Think about the most beautiful sunset you've ever seen. Well, what makes that beautiful? It's not just the colors, because the colors are just refractions of light. And it's not just that light being communicated into my optic nerve and then being translated into my brain as recording those different colors and the pattern of the colors. That's not what we mean by beauty, right? When we say something's beautiful, we have something that's non-tangible, it's not natural in its, it's not physical in its sense. Same thing with love. And we can try to look at what the effects of sexual stimulus are. For example, we see a pretty woman or we see a handsome guy. We can look at what reactions we see in our brain, what happens to our pulse, what happens to our to our blood pressure when those kinds of things happen. We can do scientific experiments about what happens to our body when we are in love with somebody. But that's not really love, is it? Right? That's not really analyzing love. Love is a non-empirical concept. We can describe it, but it's not something that is particularly well measured. Because really, when we talk about measuring love, we're talking about how people are acting, and whether they say they're in love, right, or whether they say they love somebody. But that's not in and of itself an actual assessment of love. It's a question about whether God exists. Does God exist? He may not. She may not. He may. I mean, we don't know from a scientific standpoint, because science does not have the tools to evaluate the question whether God exists. God, by most religions' conceptions, is an immaterial being that exists outside the plane of the natural world, right? Outside the realm of the natural world. Well, science, by definition, is about measuring the natural world. So by definition, it does not have the tools for evaluating whether God exists. Do you have a soul? Is there something in you that is apart from your body, right? And this is what in philosophy is the classic mind-body dilemma, right? You've got your brain and you've got your mind, right? And these two things are understood in most of humanity as distinct, right? Same thing with a soul, right? A soul is the spiritual part of you, right? Well, if that is real, the problem is that science can't tell us whether it's real because it's a non-empirical, non-physical, natural phenomenon, right? And then bigger questions like the meaning of life, right? What is the meaning of life? This is absolutely not a scientific question because science is not about meaning. Science is about studying the natural world, studying behavior. It's not about applying meaning. So when people are talking about meaning, they're importing things that are not scientific. When somebody is claiming to be a scientist and claiming to talk about the soul or claiming to talk about the mind or claiming to talk about God, right? The scientific tools that we have at our disposal are simply not built for evaluating these questions. So that's a limit, right? Science can't tell us about all these things. They can give us interesting bits of information, but these questions are not scientific in their character. Science can't help us to verify moral arguments either. Think about the argument that economic inequality, which we see all around us, all over the world, economic inequality is bad. Well, that's a moral argument. Science can't tell us that it's bad. All science can do is identify the effects of economic inequality, the causes of inequality, but making the moral evaluation that economic inequality is bad is not a scientific question, right? Because effects are not, in order to evaluate whether effects are bad or good or causes are bad or good, you have to import in moral reasoning, right? And so science is not very well equipped for telling us that economic inequality is bad. Scientific approach is excellent at identifying and measuring economic inequality. Whether or not economic inequality is bad is a moral argument, and it's not based on science. Same thing with the argument that abortion is evil. Lots of people think that abortion is evil. Some people don't see anything particularly wrong with it. But science cannot tell us whether abortion is evil. Science can tell us about how many abortions take place. It can tell us about what happens to the baby when or the preborn child or the fetus when an abortion is taking place. But in order to classify that as evil or not evil, we have to have a moral framework for arguing that, and that is, by definition, not a scientific thing. Even if we go with something as benign as saying everybody ought to vote, right? That's a moral argument that is not scientific in nature. So these kinds of value statements about what's bad, what's good, what's evil, what's noble, those kinds of things are not based on science. They're not based on scientific observations. They extend out of moral theories and people's conceptions of what's good and conceptions of what's bad and what is good for society or what's good for individuals, but it's not based on science. We also have limitations in what we can study. In the same way, kind of following off of the question about we can't really study scientifically the existence of God because God, as we conceive of it, most of us, is an immaterial being, so outside of nature. We also have things that are in nature that we can't observe. So there are some things that we're interested in studying. I'm interested in studying why people vote, who they vote for. But I am limited because I can't go into a voting booth and watch people cast their votes, right? That's illegal. There's a prohibition on doing that. Now, maybe we could go to another country like China or Russia and we can have that more observation about that. But we can't do that nowadays in most democracies. We can't really do experiments with war. So in science, if we're trying to understand the effects of war, from an ideal standpoint, the best way to do this is to randomly assign countries or communities to experience war and then to evaluate the effects of war on those that we do assign to war categories and those we don't, and compare that with the effects of people who aren't in war. Well, we don't have that kind of control, nor do we want that kind of control. So there are some things that are off the table, right, that we're not allowed to do, that we just can't directly observe. And so we come up with second best approaches to evaluating these things. Moreover, our senses have biological limitations, right? We can only see what we can see. We can only hear what we can hear. But one of the things that we do try to accomplish is having better tools to measure the things that our own senses don't allow. So think about the microscope, think about telescopes. In the natural realm, we develop better and better tools for seeing smaller and smaller things or farther and farther away. Finally, we have big concerns. Even though human reason is considered to be a relatively reliable means of gathering information and interpreting it, we also have to be humble in terms of understanding that there are reliability concerns about our human reasoning ability and the way we process information. Our perceptions are often limited. For example, we're affected by the fact that we can't imagine everything. Right? One of the things, the reason that we love science fiction is because somebody has taken the time to really develop an alternative understanding of the world. The reason the Marvel universe is so exciting is because they're conceiving of something that's completely different than what we understand in terms of, for example, the multiverse and the way that that would work, and how would that be if it were a real thing. We also have our own cognitive biases. We're not completely neutral. We come at the information that we gather from a certain perspective, and we have assumptions about the way that the world works and about what it means. So we have cognitive biases. Party identification, for example. Republicans view the world in one way, Democrats view it in a different way. But there are lots of other kinds of things, of biases that operate on the way that our minds gather and process information and attribute meaning to that information. And so we have to be very cautious and humble about that. And as political scientists, when we think about these last two bits of limitations, we need to kind of use our imagination to think about how could we gather information about things that are maybe be difficult to observe. Or if we can't measure something, what is the second best thing that we could find to get at the thing that we're really interested in measuring? And then we think about our own biases. A big part of political science is trying to communicate on the front side what our underlying assumptions are of our analysis, and to describe why we think what we think, and to try to be intellectually honest about the way that we're interpreting the world. That doesn't always work, because political scientists, remarkably, are human beings too, and so we mess up too. But a big part of the candor of a scientific enterprise is being able to be aware of one's own cognitive biases and one's own limitations, and then striving to overcome those. So in a nutshell, those are the kinds of underlying assumptions and limitations of social science. We certainly could have gone into a lot more detail, but in this case, we kind of hit the peak of the mountaintop, and just to get a sense of how complex these ideas are and how important they are in terms of what we're trying to do as political scientists, as people trying to take quantitative information and use it to build our knowledge about politics and society.